So this is the fiber optics experiment setup. It is to be conducted in the with maintaining darkness. But here, for the sake of clarifying the steps, we'll have the light on, and Arnav is the final year postgraduate student, MSc, solid state, and now he will be performing just clarifying the different steps to be followed for this experiment. Okay, Arnav.
This is the source, and this is the source, laser source, and this is the source is fitted here, and from this point there is a lens, and from the end part of the lens there is an optic fiber which ends here, and from this is an photodetective sensor connected here, and from this point we are measuring this voltage in a multimeter. Now first of all we will switch on the circuit. Now we can see that the voltage here, that is 174, and as the scaling here is milliscale, so this is 173 millivolt. Now if we power up the circuit for a moment and turn all the room, this will change. That means this sensor detects the light. Now for the sake of simplicity we are switching on the light and measuring, explaining the experiment. So there is a two screw here. One of them is for vertical change, and another of them is for perpendicular change. Now if we change this screw here, we can see that this reading is also changing with changing this screw. Thereafter, and if we change this screw also, this reading will also change. Now before starting the experiment we have to level and this tail end of the optic fiber and this photodetective sensor, and there is a circular scale, and the scale division here is 2 minutes, or rather 2 degree, and we can easily compute the Vernier constant. Now there is a perpendicular position, or we don't know in which orientation this photodetective sensor is fitted here, so we have to see that there will be a position where this voltage will be maximum, and this is, we can see that somewhere where this is the maximum voltage, or this is the maximum voltage. There is a fluctuation.
162.
After that, if we change this
position of
this detector, then we can see this will change. Rather, if we just switch off and on for a moment, as this is a digital device, so there may be some lag. And if we again rotate it, it will change. So through this process, first of all from left to right, and then from right to left, we have to perform all the experiments. Thank you.
Okay. So what you will do during this experiment, let me have a very close look for this one. This is the laser source, and the wavelength that is written there. The wavelength exactly the power supply. It's with a 12 volt DC, 100 milliampere. The power source for the laser. This is the power source, and this is the laser. Normally, the laser is labeled with a. So if this is the level over the laser. Okay, and they just pass on the information for the wavelength, and this is the fiber optic cable which is coming to this side, and this is a top view, and this already Arnav explained, and there is a Vernier scale there, and this is the circular scale having a 2 degree deviation. So you can closely find that in between 20 and 40 you have 10, so 20 divided by 10 is 2 degree. Okay, so you'll have this laser finally coming out, and you just put it off, so you can quickly check that the reading goes down to 0. Not exactly 0 because some scattered light is there. Okay, so if I change it to different position, it should go down the point that he shared. But if I just move it away from the direct, so I'll get the reading to change. Okay, similarly if you just rotate it to the right side, I'll get it to change. So you need the reading for the flux meter, the optical flux meter at different positions. Okay, so that's the enter setup.